Okay. Um,
Yeah, so regarding the output of passing that code through Reaper,
yeah.
those numbers that exist at the very start. I don't know if you could share your screen and they show you those numbers that exist at the very start before you see the token.
Hold on. Let me share my screen.
Yeah, in the terminal. That was after you ran the code.
Oh, what?
It's okay, we can use the one from
Yeah,
the
this
text.
this one here.
Yeah. So there's these numbers that appear on the very first line when we are getting the token for the integer.
Hmm.
We have 1 0. So I have a question. This one and then the two that appear in the first column, are they signifying a change in, are they signifying that we move from the first line and then we'll go to the second line at the start of the put, because the put is inside the do end block, which is technically the second line.
Yep.
I don't know if
That's
that's what they signify.
yep. This is line one.
Yeah.
This is line two. It's the start of line two. So this is the zeroth character. Um, this starts at uh, index number two. This times starts at index number three. So yeah, that's what that means.
Okay. And then what about the argument, like at the very end of after the token, the dot arg, and then yeah.
Mm, sorry. Oh, so this space, or do you mean this like on period is a dot?
No, I mean like what is printed in blue at the very end of each line in blue and white.
Oh,
Yeah.
um, that's a good question. They seem to be so like arg stands for argument, maybe.
Yeah, that's the
I'm
only one
actually
I'm
not sure.
familiar with.
I'm actually not sure, and I don't think the book went over that. No, because the book doesn't have that ending.
Oh yeah.
It doesn't.
Okay.
So I'm not sure what it is, but it looks to be some other different type of classification.
Okay. So yeah, that's what I had. That's the question I had. I think we can proceed.
Okay. Um. Yeah, that's a good question. I didn't even consider these at the end. Maybe no, I don't know. I don't know. Okay, parsing. Uh, it is wrong. Um, this says Ruby uses Bison. Bison is no longer the parser that is used. Um, the new parser is called LRAMA. Uh, and this is, as I was reading this, I Googled, hey, is Bison still what Ruby uses? And I found out, no, it's not. So LRAMA has been the new generator since 2023. Um, but it seems like all the parsing rules were kept as close to the same as similar as possible. So the grammar rule file is in this Parsi file. So anything that we read here is still going to be valid because it's still got the same rules. It still fits the same role as as Bison. El Rama still fits the same role as Bison. and it's got the same inputs, so it's gonna work similar, at least in concept, to what Bison does. And I also, because it specified what files these rules were in, I also downloaded the Ruby source code. Um, oh, come on. Do you see my screen? Do you see that I'm drawing circles on my screen?
Yeah,
How do I get out of this thing? Clear.
I don't know. Last time you stopped the sharing, and then when you shared again, it wasn't there. So
Yeah, I want to know why it's happening though. Okay, I'll just stop the share and then start it again. Silly. Nope. What? Okay, I'm just gonna have to deal with having. Why can't I drag this? Okay. Uh, what was I doing? Oh, I was the Ruby CD. Okay, so the grammar rules are specified in Parsi, this file. And if we open up this file, we can come in here and look at what's in this file. Um, and frankly, uh, for me, it is also hard to understand what's going on. There's a lot of code here. There's a lot of there's a lot of methods. Okay, but basically, these tokens are interesting. Um, they're the they're going to be like switches for changing our behavior when we encounter them when we're tokenizing. Um, yeah, just a lot of stuff defined in this parser file. Um, okay, but this chapter explains to us what these grammar rules are like, and it uses um, this example of translation from English to Spanish or Spanish to English. So basically, it's going to define a rule called Spanish phrase, and the rule is uh, basically when it encounters this, it's going to print "I like Ruby." So, um, I mean, that's a simple rule. It translated when it encountered this text, it translated it into this text. Okay.
yeah,
Um, you can compose these grammar rules. Oh, you can compose these grammar rules so that you have something as a verb and object. So this is a grammar rule called Spanish phrase. It is composed of another grammar rule called verb and object, and the text El Ruby. So let's take a look at this grammar rule, verb and object. So this verb and object is she likes, I like. We're going to do some translation between those things. So she likes is another grammar rule. I like is another grammar rule. So this verb and object is when we encounter either this or this, we're gonna replace that text um, with the text that we find in the grammar rule. Okay, so what is she likes? Le gusta translates to whenever we encounter the direct text le gusta, we're going to output she likes. When we encounter the text me gusta, we're going to output I like. So let's say the text is me gusta, it's going to put I like. So it's it satisfies this grammar rule. So here we're looking for one or the other. She likes or I like. So we found I like. We're going to replace the. So we've already replaced me gusta with I like. It comes here and now I like goes into verb and object. Verb and object basically just says, I'm gonna when we find me gusta, I'm gonna print this out. Ugh. Okay, that was harder to explain than I thought. Um, so yeah, I mean, basically, it's what I've already explained. Um, Le gusta el ruby. It's gonna get taken through all each of the grammar rules. The grammar rules um, are composed with each other, and so at the end of the day, uh, when that Spanish when it ends at that grammar rule Spanish phrase, it's going to reduce and match it to the whole translation that we had. Either I like or she likes Ruby. Okay, so let's see. Uh, and actually, so here it's telling us that you can do this Ruby Y simple .rb, but it didn't work for me. Ruby Y simple .rb. Yeah, it doesn't spit out anything. And I don't know why. It's possible that my Ruby uh, installation didn't come with debugging and that I have to pass a flag to get debugging support in Ruby. And that's why I don't see any of this stuff. The Ruby command, if you type help or help grep, grep is just basically to search through the help or to search through the text of the previous command. So we're going to do dash y. Nope, grep uh, debug. So it exists. It still exists in Ruby. Dash y should work. It's just that my particular Ruby doesn't have it. Okay, so basically these are some real grammar rules. We have uh, these grammar rules defined. Um so program is the whole program. It's made of uh, this computer statement or top computer statement. Top computer statement is composed of top statements and optional terms. And so these grammar rules have other grammar rules, have other grammar rules, all the way down the stack. Um, so basically, when we get all these tokens, it's going to process them through these grammar rules. And and then spit them out as uh, something more meaningful. Oof, I'm losing steam here.
Yeah, I think the next part we should just proceed to the next part, the one which goes into the tree, the AST.
Yeah, using Ripper to parse different Ruby scripts. Okay, this did work for me. So we're gonna copy this into our interpreter and just take a look at it there. Okay, so basically we're yeah, we're basically looking at the abstract syntax tree, and it's a little hard to look at it this way. The indentations uh, are a little hard to track. It is easier when you look at it in this view here, where you have this command args add block identifier puts. Okay, so let's try to find those. So we have this puts n. So we have this identifier puts. So that's what we're looking at here, identifier puts. And then this other variable reference called n, um, which is here on this bottom of this
Yeah,
stack here.
yeah.
So basically, it's just creating this thing that is called an abstract syntax tree, and it's basically parsing out the different parts of the instructions into this tree that you can see here. It's do I have? Oh, that's why this is one line. Okay, yeah, this command statement was yeah, this is the bottom of it. Um, okay, so this do block. I mean, we can see that the each of these sections is going to be a different part of of the different commands in this abstract syntax tree. At the top level, we have program. The
Yeah.
We have a method
Method add block.
times
Yeah,
add block.
yeah. And then call.
So for this, we have the code is just 2 plus 2. So if we look at that, we have the start of the program. We have this binary. I'm not sure what binary means in this context. Binary instruction, binary operation. Uh, but we have this method plus that's operating, so it's going to be 2 plus 2.
Oh, it says in the text that the plus is represented with an AST node called binary.
Oh, okay,
Yeah, the plus sign, which is the addition we're doing in that example.
okay.
Yeah,
And then here it's saying 2 plus 2 times 3. Obviously, in mathematics, you want to do 2 times 3 first, and then the
yeah.
addition because that's the order of the operations. And then it said, based on the syntax tree, that is what's happening first. You have the 2 and the 3. That's happening first. and then you have the addition with the two. And this is what the syntax tree looks like. And that was the end of the chapter.
Yeah, that was a hard one, but the first part you did, it clarified some of those things, some of the things that are talked about in the chapter. And then I don't know if you had noticed the Reaper example, but the way he references the tokens initially, he uses words like, let me refer to the text. He uses words like t integer and then t identifier at the start before he
Hmm.
introduces the concept of Reaper. And then when it comes to Reaper, he when it comes to the output that Reaper gives us, we get on indent, which I think is supposed to be similar to T indent, and then others are like on int, and then on underscore int, which I think is supposed to be similar to T integer.
Yeah, t integer here. Okay,
Yeah,
so here's what's happening. The when you are writing the interpreter, so as Matsumoto, when he sat down and he started writing C code for this, you need some way of distinguishing the C code that you're writing from the Ruby interpreter itself. In your C code, you're gonna have these things that are types. Um, so let's just take a look at. Do we have a integer? No. What's a good file? Sig. No. Okay, so you have you have this thing called a like RB atomic T. Um, how do I explain this? Okay, so you have types in C, right? Like that you want to use to program. But you don't want to get those mixed up with types that are supposed to be used for Ruby. So you have something. So let's say, let's just open up. Let's just use Chat GPT. Not now. Please define an integer in C or declare. So when you declare an integer in C, you have to use int, right? Like this is
yeah,
int. Um, so if I then said, oh, my Ruby types are going to be called integers, well, it's super confusing because then it's like, well, is this meant to be used for my internal code or is this integer meant to be used for defining Ruby stuff? Do you understand what I mean? Or is it still confusing?
no, it's still kind of confusing.
Um, do you know what types are?
No, I just hear references to the term TypeScript.
Uh, okay. Types. Let's ask ChatGPT. Are types? Yeah. Okay. So you remember we talked about bytes. 4
Yeah,
bytes or let's talk about 2 bytes. 2 bytes is 16 bits, right?
Yeah.
So this short is 16 bits long. And when we are using this short, this short means um, it's going to be a number. It's going to be, uh, well, I don't want to discuss signed versus unsigned. Let's just imagine that it's just a regular number. Uh, so let me take my IRB. 2 to the power of 16 minus 1. So it's going to be able to represent 16 zeros and ones. So, 16 zeros and ones. And actually, we can represent this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if I type in these 16 ones and zeros as binary, what number is this going to represent?
I think 65535.
Exactly.
Yeah.
And that was 2 to the power 2 to the 16th minus
Yeah.
1. Um, okay. So in C, what we say is that we're going to define a type. And actually, in C, you have to think of types a little bit differently than in other languages. Because in other languages, you're free to define types and think of them like objects, like things. In C, types are more like how much memory you use. Because here we're saying we use 2 bytes of memory. Why do we say that? It's because when the machine reads some area of memory, all it's looking at is, and C is a very low level programming language, but basically, C is going to see a whole series of ones and zeros. And maybe I should have diversified the ones and zeros here. Uh, but basically, it's going to go how does it know what's part of a number and what's part of the next number? It's these types. So if we say that that you have shorts that are 2 bytes long, it means that the processor is going to go over here and say, I'm going to take the first 16 bits, and that's a number. And then I'm going to take another 16 bits, and that's a number. Oh, but this other place I've specified an integer, which means because it's an integer, I'm not going to take 16. I'm going to take 32, right? So I'm going to move 32 over. And that those 32 ones and zeros define what type it is. And really, we're thinking in C right now. We're not thinking in any other programming language because this is what Ruby is written in, and
Yeah.
this is what we're talking about, right? So
Yeah.
in Ruby, the integer, the size of an integer is not defined in the spec. So the Ruby interpreter is free to make integer take up 32 bytes or 64 bytes. And it's up to the Ruby interpreter to define how big that size is. And in the MRI Ruby, it's the default size is 32 bits. In JRuby, the default size is 64 bits for an integer. So when we say in the code that we have this type, that is called T integer. What that means is that um, w- that we want to separate the integer that we're using in Ruby from the integer that we're using in C. In here, this integer is 4 bytes long. In here, it might be 4 bytes long, but it's not guaranteed. It could be 8 bytes long, you know? Um, we have less than 10 minutes left. Um,
Yeah,
so did that clarify anything for you?
yeah, kinda. It did.
Hmm,
Yeah.
I'm not convinced. Don't lie to me.
Some of the things make sense. I don't know. I was trying to read about how the each method is actually implemented, like the one you used to loop through, like an array. So I was trying to read about how it's implemented, and some of these things came up because that's actually how I got to know that Ruby is actually written in C with the whole MRI thing. So they make sense partly, and then others seem very flimsy.
Hmm,
Yeah,
okay. Yeah, I mean, a lot of this stuff, it's not expected for a beginner to understand any of this stuff. This is pretty advanced stuff. This book is pretty advanced. Um, and it gets to a lot of details about Ruby that a lot of professional Ruby developers, don't know about and don't care about, and they don't have to care about it. You can get by without all this knowledge. Um, it's doesn't for a lot of purposes, like if you're using um, Ruby for web development or a bunch of other stuff. Like you don't have to get into the low level details of how it's implemented in order to use it well.
yeah, it seems interesting though. So me, I think we'll just go through it. Maybe I'll return back to it after a while. Maybe when I've gathered more knowledge. But we can go through it. It's fine with me.
Okay. I
Yeah.
mean, it's helping me. This is all of this stuff is stuff that I don't well, I don't know. Like I didn't know before I read the first chapter that the Ruby interpreter is split up into a tokenizer, a parser, and then a compiler. Yeah, that was all new information for me. But I'm glad. Like I want to know this stuff.
Yeah. So I think that's it
Okay.
for today. Yeah.
Yeah, I'm tired. It's exhausting to talk for so long.
Yeah. Okay, Nelson. I think I'm going to end the call.
Okay, see you next
Yeah.
week.